Hi everybody, welcome to the video. My name is Jov and this is Test-Driven Development Screencast continuation where we left off in the previous video. Just a little reminder that this episode is the one before the last one, so we're gonna have this one plus one more for this season, and then we're gonna continue at the beginning of September. So let's see where we left off in the previous one. As we said here, the plan is to have the loading states exposed from the view model towards the UI, and we have the thread switching. So that's gonna be the aim for this video, and in the next one we are gonna complete the UI of the timeline, and then we are gonna go on a break. So let's see how we're gonna go about this. As always, let's go ahead and start by writing a test. So we are gonna write a new test in the timeline, and let's name this rendering timeline states test. So I didn't warm up the machine before recording, so maybe it's a good time to run the tests and make sure it's gonna warm up. So I did a typo here. Let's fix that one. It's gonna be rendering timeline state test. Okay, says that it didn't find a test. So now it is not compiling the test. Okay, that's fine. So for the name of the test, we wanna see what happens when we have UI states, well, timeline states exposed to an observer. So we want to make sure, let's import this. So we want to make sure that a list of timeline state loading, and then timeline state posts, let's say empty list for now, because what's important here in this test is to make sure that the states are delivered in particular order, and that's basically the only thing that we care about here, not the particular data. That's something that we've covered in the other tests. So that's gonna be the rendered states. And now let's work towards making this compile. So first of all, let's close the panel on the left, and actually all panels. In here, yeah, it's not allowing me to create inside the timeline state an object. So what I'm gonna do, I'll create it manually. So an object loading, that will be also a timeline state. And what are the rendered states then? The rendered states are gonna be a mutable list of timeline state. And then what we wanna do, when we call ViewModel timeline for, I don't know, irrelevant ID, so we are gonna try to fetch the timeline for doesn't matter the ID. We are gonna expect loading and then empty posts with like no posts inside, because this user wouldn't the ID of this user will be something new, something unknown. So let's create a view model then. And a view model is gonna be a timeline view model. Let's actually pull it up. And then here we have to pass timeline repository. A timeline repository is gonna be a timeline repository where we're gonna pass an in-memory user catalog, empty one, as well as, let's do formatting as well as in-memory post catalog. And one last important part is to observe on the states that are being exposed, on the live data from the view model. So here we have to say the view model, oops, come on, timeline state observe forever, and then here whenever we receive a new state in this observer, we are just gonna add it into the rendered states. So we are observing the timeline states, and whenever we receive new one, we are gonna add it into the rendered states. Then we make the call to get the timeline, and what we expect is loading and then the actual rendered states. That seems good to me. Let's run and watch it fail, which is pretty important. Oops, the results are on this part of the screen. Let me make it bigger so it's gonna be more visible. So we have a failure, and it says that we have a problem with the looper. So what we're gonna do is here we're gonna do extend with instant task executor extension, then run again. That should make it work. I mean, make it work in terms of failing for the right reason, and it does fail for the right reason. We're expecting loading and then posts. What we got is just posts. So how do we make this work? Let's move it on the other side. How do we make it work is by actually saying here mutable timeline state value is gonna be a loading for the one from the timeline here. Let's make sure that works. It does. So that's cool. Now let's check this in first. So what I've done here is I'll say delivers UI loading UI states, no, delivers UI states to the observer in correct order. That's good. Now let's do a little refactoring here. Basically I want to pull all this setup outside from the test. So I have the timeline repository, I have the view model, and what I do here, I create rendered states, I observe, and then just a simple act, and then the assertion. Good, let's run and make sure I didn't break anything. Nice. And then let's check this one in. Removed irrelevant details from inside the test. Cool. So if I go back here, the loading state is complete, but now we have to do the thread switching as well. So what we want to do here is basically we want to offload the timeline repository, get timeline 4. We want to make a call. We want to make that call in a background thread. So we want to switch the coroutines here. But as usually, we want to start from, let's first open the in-memory post catalog. And if you open, I'm gonna open these to the right. The post catalogs, this one here is just a regular function. What we want to make it is a suspending function. So whenever we write a post catalog, whether it's going to be, let's say, memory call, like memory post, like, sorry, not memory, rather database. So if we have database post catalog or remote post catalog, those kind of things, they should expose they should have a suspending function, because making calls to remote or to database are always time consuming, so we want to do that. That's like why we are starting from this and then working backwards. We've done the same for the sign up, we're gonna do the same here. Okay, so now if I run the tests, the compiler will be, you know, driving me backwards towards making everything as it should. So here, for example, we are overriding in the in-memory post catalog, we are overriding the function and it's not suspending. So what we can do, just add suspend, just follow the compiler and then work backwards. So here in the timeline repository, we are also gonna make this one suspend, and that's gonna work fine. And then we came back to the view model. Now here in the view model, we have to call this one under a coroutine. So first thing that we can do is we can do a view model scope launch, and then we can do this inside a coroutine. Now I'm just running the tests, and the tests are passing well, so everything works fine. Except that we are still here when we call launch, we are in the UI thread, and we don't want to make these calls in the UI thread. We want to do everything from this view model onwards. We want to make it in the background thread, so the UI is not gonna be blocked. But first of all, let's check this in to make sure we are gonna, you know, this check-in is like making a checkpoint, so it's gonna be easier to revert to this point rather than reverting to too many like points back. So the closer we get, the better. So just to double check what we've done here, we just created the suspend function. We are calling this into a, so nothing much changed. So here what I can say, intro a suspending modifier along the layers for the timeline. Good. And now, as I said, what we want to do is here we want to change, we want to make this call in the background thread. So first thing that we can do is here, because we already have a dispatcher, so instead of creating here something that I would then pull it up in the constructor, I already have something, so I can just directly here change the signature of the constructor of this class. And by changing the signature, by doing this as an automated refactoring, it's gonna be easier for me because the studio will do the work for me. I would have to do way less work. So let's see. So here we have a we are injecting only repository. What we want to do, we want to inject another val, which is gonna be dispatchers. And we have, I think, coroutine dispatchers. That's the one, the type that we want. What's gonna be the default value? The default value is the value that's gonna be replaced whoever is making instance of this class. We can say, let's say, test dispatchers. Oh, it's not available because it's in the production. So let's say instead of test dispatchers, let's say so I don't know what is the, let me first figure out the implementation. So if I do coroutine dispatchers, and this one is being implemented in default dispatchers and test dispatchers. I have to use the default, I think. So let's retry this again. So I'm just gonna add val dispatchers, coroutine dispatchers, default dispatchers. Okay, good. So let's make this refactoring. Now I'm gonna make this private, and at this moment it is unused. Let's run and make sure we are still fine, except I think for the tests, because in the test the default dispatcher is not available. Yes, just like I was assuming. So here I just have to do test dispatchers instead, and let's replace that here as well. And I think in my, so that was one test. I think here I have to do the same for the view model. Let's maybe do a little formatting. And we have some more tests where we need to replace the dispatchers. So we've changed across all the tests, and now all the tests are working well. So what we can do here, just check in and say, yeah, and even in the view model, in the module for the coin module, we got the correct setup. But I think I don't want to do it that way. I just want to use a get instead. So let's change that one too for this commit. So module is gonna be my application module. So here the dispatchers, because I already have the default it is already something that I have defined here. So what we can do here, we can just do get. Simple as that. Let's make sure everything is working well. The tests are still running, they do. And if I go back here, that's what I wanted. So here I just introduced the dispatchers, and I replaced, I've added the dispatcher as well as constructor argument in the tests. So everything is just fine. Let's check this in, and I'm gonna say introduced the coroutine dispatchers as a constructor argument in the timeline view model. Good. And now here we can just do the offloading. So we're gonna say that the result's gonna be with context, dispatchers, background, And now I'm just gonna run the tests and everything should be still fine, and it is. That's great. And I can perhaps inline this as well. And that should still work. It does. Let me check this in. So what I'm gonna say is loading the timeline is done in the background thread. And now let's see where we are. So we got the thread switching. Backend exception plus connection available exception, unavailable exception in contract. Yes, I think. Yeah, that's fine. We're gonna do that once we make when we'll be implementing the real calls to the backend. For now, I think we work with everything in memory. That's like not necessary. So what's left is the UI. I think if I start working on the UI now, I'll need more like 30 minutes or maybe more, depends. I'm just assuming, because there will be some things that I'll have to, explain on the way. However, I think that's gonna be what I'm gonna be doing in the next episode, as I said at the beginning of this video. So I think this is gonna be enough for this one. I think we've done a good job. We just pulled everything together, and what's left is just to do this representation in the UI. Of course, we will need to write some UI tests to make sure that the loading is being presented and that kind of things. And as I said, that's gonna be something that we'll be doing in the next video. So thank you so much for the attention and for the time of watching this video. I'm gonna make sure to catch you in the next one. So have fun. Thanks for watching.